So far in chapter 8.2, we've noticed if it's in the form of 0 over 0, we can use L'Hopital's rule. We've also seen if it's in the form infinity over infinity, we can use L'Hopital's rule. Now we're going to talk about some other indeterminate forms where we have to do algebraic rewriting before we can use L'Hopital's. These are forms that include 1 to the infinity power, 0 to the 0 power, and infinity to the 0 power. And the way we're going to get around this is by taking the ln of both sides, and we're going to create fractions, because L'Hopital's rule only works if you have a fraction. So we have the property that says if the limit as x approaches a of ln of f of x is equal to L, then the limit as x approaches a of e to the ln of f of x is equal to e to the L. Basically, we're just raising both sides by e. In example 8, we're going to look at an example where we get something along the lines of 1 to the infinity. So the limit as x approaches infinity of 1 plus 1 over x to the x power. If we use a direct substitution, we're going to get that this is 1 plus 1 over infinity to the infinite power. This is going to give me 1 plus 0 to the infinite power, which is 1 to the infinite power. This doesn't really tell me anything about the function or the limit that it gets towards. So what we're going to do now is we're going to go ahead and do some fancy algebra to make this work. So we're going to let f of x equal the function right here. So that's 1 plus 1 over x to the x power. And now what we're going to do is we're going to take the ln of both sides of that function. And what this is going to allow me to do is take this exponent and bring it down to the front. So we get ln of f of x is equal to x ln of 1 plus 1 over x. So what we've just done is the limit as x approaches infinity of ln of f of x is equal to the limit as x approaches infinity of x ln of 1 plus 1 over x. Now our goal is to make this into a fraction. So this is actually going to become ln of 1 plus 1 over x divided by something. And the way we're going to do that is by doing some fancy algebra. And so rewriting this as a fraction, I'm going to get the limit as x approaches infinity of ln of 1 plus 1 over x divided by 1 over x. So now what we're going to do is we're going to do our direct substitution and see what we get. So if I let x become infinity, I get this is ln of 1 plus 1 over infinity divided by 1 over infinity, which is going to give me ln of 1 over 0, which is 0 over 0. This is what is going to allow me to use L'Hopital's rule, because I have 0 over 0. So this is equal to, by using L'Hopital's rule, and pay close attention because this gets kind of tricky, the limit as x approaches infinity. The derivative of ln of x is 1 over the inside, 1 plus 1 over x, times the derivative of the inside, and the derivative of the inside of this function is negative 1 over x squared, all divided by the derivative of the denominator, which is negative 1 over x squared. So now we're going to get that these cancel off. And I can rewrite this as the limit as x approaches infinity of 1 over 1 plus 1 over x. At this point, I can go ahead and use my direct substitution. So I get that this is equal to 1 over 1 plus 1 over infinity, which is going to become 1 over 1 plus 0, which is then going to become equal to 1. However, we're not done with this problem, because originally we took the ln of both sides, so we have to finish this off by raising it to the e. So the conclusion we're going to make is that the limit as x approaches infinity of 1 plus 1 over x to the x power is equal to the limit as x approaches infinity of f of x, because this is f of x. And then using our property from the very beginning, we can rewrite this as the limit as x approaches infinity of e to the ln of f of x, which is going to be equal to e to the limit as x approaches infinity of ln of f of x. And this part we just showed that that's 1. So we get this is equal to e to the 1, which is just equal to e. The shorthand for that is actually just to write an e right here. So you raise your final answer to the e. On your own now, I want you to try to determine the limit as x approaches 0 of e to the x plus x to the power of 1 over x. All right, here we go. So if we do a direct substitution, we get that this is e to the 0 plus 0 to the power of 1 over 0. So this is going to give me 1 to the infinite power, which is not helpful. So following the same steps as before, we're going to get that our original function is f of x, e to the x plus x to the 1 over x power. And then so ln of f of x is equal to 1 over x ln of e to the x plus x. And this can be rewritten as ln of e to the x plus x all divided by x. So now we're going to try to apply the limit and see what happens. So the limit as x approaches 0 of ln e to the x plus x all divided by x is going to be equal to ln of e to the 0 plus 0 over 0, which is going to give me ln of 1 over 0, which is equal to 0 over 0, which is an indeterminate form, which is a good thing because now we can use L'Hopital's rule. So using L'Hopital's rule, we get that the derivative of the numerator is 1 over the inside e to the x plus x times the derivative of the inside, which is going to be e to the x plus 1, all divided by 1. So we want to take the limit of that. So the limit as x approaches 0 of 1 over e to the x plus x times e to the x plus 1. We can rewrite that as the limit as x approaches 0 of e to the x plus 1 all over e to the x plus x. And now we can use a direct substitution. We get e to the 0 plus 1 over e to the 0 plus 0, which is going to give me 1 plus 1 over 1. So our answer is then 2. However, we're not actually done, because we found what the limit as x approaches 0 of ln of f of x. So our final answer then is we need to raise it to the e. So our final answer should be e squared. However, we're going to confirm and make sure that's right. So if this is an FRQ, we would write that with 3 dots. The limit as x approaches 0 of e to the x plus x to the 1 over x is equal to the limit as x approaches 0 of f of x, which is equal to the limit as x approaches 0 of e to the ln of f of x, which is equal to e limit as x approaches 0 of ln of f of x. And we showed that the limit of ln of f of x is just 2. So our answer is e squared.